All right, today we're doing section 5.1 on the basic rules of exponents, working out of the Green Book, page 207, 1 through 70 odd. Sounds like a lot, but it's not really. It probably will take you no more than 15 minutes. All right, so our objective is to recognize the properties of exponents and use them to simplify expressions. We're basically learning the rules of exponents, and so before we even begin, I want to talk about what does this mean? What does this mean? Yes, Rami.
It means x times itself 3 times.
X times x times x, right? Okay, there are two parts to this expression. There are two parts. There's a base and an exponent. I need you to know what those two things are, because when you are messing up with your exponent rules, I'm going to ask you, what is the base? So the exponent is 3 and x is the base. Okay? Now the rule of common bases is that if we have the same base, x and x, then we can add the exponents. Okay? So for instance, if I have n to the third times n squared, instead of expanding that out, which would take a lot of time, you can see that we would end up with, if we expanded it out, n to the fifth. But instead of doing that, if we take our exponents and we add them, when we have a common base, and they're being multiplied together, two terms are being multiplied together with a common base, we add the exponents, 3 plus 2, we get the same result. Now this really helps when we have exponent terms like x to the 100th plus x to the 500th. Nobody wants to write out 100 x's and 500 x's. So if we use our rules of exponents, then we know we have x to the 600th power. Okay? Questions? Pause the recording if you want to write the notes. Okay, so let's try. Why don't you try all of these on your own? Or let's do the first couple on our own. So number 1. 2 to the second times 2 to the third really means 2 to the second plus the third power. That simplifies to 2 to the fifth. And 2 to the fifth is reasonable for us to simplify further. Okay. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay? If it's reasonable, 4 to the 7th, not reasonable. I would expect you to use a calculator. Okay. What about number 2? What is the exponent for the second term?
3 to the power of 3.
No. I said, what is the exponent for the second term?
1.
Go. Can you answer the question?
3 to the first power.
To the first power. So now when I'm using my rule of exponents, I'm doing 3 to the second power plus the first power. So that makes 3 to the third power. Okay? And that really simplifies to what? 27. Yeah. Okay? What is the base of the exponent? Very important here. Number 3. What is the base, Rami? Number 3, what is the base of the exponent?
Negative 2.
Negative 2. The entire, both the negative and the 2 are the base because we have a parenthesis. Do you understand? Because we have a parenthesis. If it had been negative 2 to the third power, that would mean this. Negative 2 times 2 times 2. What gets repeated? Just the 2, because the base of this exponent 3, what is the base of the exponent? Only the 2, when it's touching. Do you understand? So here, the base of this exponent is just the 2. But here, the base of that exponent is the entire quantity inside the parentheses, the negative and the 2. So both get repeated 4 times. Does that make sense? Yeah. So then we get, it's negative 2 to the 6th power. I should do 4 plus 2, right? 4 plus 2, let's keep it consistent. 4 plus 2, and so that makes negative 2 to the 6th power. It's an even quantity. Negative times negative times negative times negative times negative times negative. 1, 2, 3, 4, 5, 6. Every 2 makes a positive. So what's our answer going to be?
64.
2 positive 64, yes. Because 32 times 1 more 2 is 64.
Yeah, if it goes to the 7th, it would be negative.
Right. If it were an odd number, it would be negative, yes.
Do we have to write the 2 plus the 2 plus 1 power?
Okay, while you're doing it now in class, I want you doing it to create the muscle memory. When you're doing homework tonight, you can just write the problem and the answer, okay? Do you understand what I'm saying? I want this just embedded in you for muscle memory. Okay, you guys do 4 through 6. Pause the recording. What is this simplified to?
4 or 5.
Number 4?
4 and an exponent of 5 plus 2, which is 4, and an exponent of 7.
Good. And did anybody multiply it out? No. Okay. We are going to use our calculator on the computer. And well, now they've got the answer. It's like 16,000. All right. Next one. Number 5. Number 5. What is the base of the exponent, by the way? Everybody. 1/2. So, I'm doing 1/2. This really means 1/2 2 times, 1/2 3 times. It's 1/2 to the 5th power. Yeah. We can multiply it like this, or we can say 1 is to the 5th power and 2 is to the 5th power. Okay, 1 to the 5th power is 1, and 2 to the 5th power?
32.
Right? If I just put it, you really shouldn't write it both ways. So 1 to the 5th power and 2 to the 5th power. And what does that simplify to? 1 over 32.
I didn't think of it.
Another way you can look at it is this really means this. 1 times 1 times 1 times 1 times 1 is 1, and 2 times 2 times 2 times 2 times 2 is 32.
But isn't that the same thing that we're trying to do?
Yes, it's the same thing. I'm showing you there's 2 ways. Okay, number 6. How about Mark?
On number 6, so I didn't simplify it all the way. I just got to 32 times 81.
How did you get to 32?
Okay, so I simplified it to 2 fifths.
No, it's not 2/5. It's 2 to the 5th power.
2 to the 5th power times 3 to the 4th power.
3 to the 4th power. 2 to the 5th power is 32. Times 3 to the 4th power is 81. And when you multiply that, did anybody multiply it out? No?
It's 2,592.
Yep, correct. Okay, questions? All right, moving on. Now, let's talk about number 3. Let's talk about number 3. We've got coefficients and variable terms, okay? What is the coefficient of the second term in number 3? Yes?
1.
1. So when we have, terms like this, we multiply coefficient with coefficient, like base with like base. Okay, so 3 times 1 is 3, but remember the rule for exponents is we add, so it becomes 3m to the 7th. Okay, questions? I don't want anybody moving ahead right now. Okay? So now, I want you guys to do 1 through 6. Okay? Pause the recording, and we're working on 1 through 6. Okay, Shivam. Number 1.
So it's you would x7, but x over 7.
You can just give me the answer, okay? x7, x to the 7th, and number 2, how about Dakota?
Number 2 was 7x8.
No, hun. Number 2.
2, not 2.
I skipped that one. Can I do it real quick?
You don't even look at it. It's mental math.
K, 11.
K to the 11th. Say it again.
K to the 11th.
Okay, say 7x to the 8th.
7, 8. 7x to the 8th.
Right. Say x to the 7th.
X to the 7th.
Okay, you guys have to speak your exponents correctly. To the. That's how we say them. Okay, next one, number 4. Why don't you tell me, Dakota?
Number 4, 7x to the 8th.
Good. Next one, Alan.
I got a to the 5th plus 9
A to the 5th.
plus
No, not plus. There's no plus signs.
a to the 5th and to the 9th.
Good. Make sure you're not adding a plus sign. Everything's straight multiplication.
I got A to the 5th times 9.
Times 9?
Times n to the 9th.
It's the same thing, but it's repetitive. When next to means multiplication. Okay? Next one. How about Roman?
I got negative 3a to the 9th.
Good. Okay. There we go. Questions? Okay, moving on. Okay, so when we have two variable expressions with coefficients, remember, we said coefficient with coefficient, like base with like base. So 2 times the 5, remember, the coefficients we multiply, but the exponents, what do? We add them. So this becomes 10x to the 7th. Okay? Oops. All right, let's do the first one together. I'm multiplying coefficients first. Max, what does it come to?
It would come to 24a to the 12.
Perfect, because we're adding. I'm going to add an extra step. You can just go right to the answer. Problem, answer. So it's really 8 times 3, a to the 5th times a to the 7th. It's 24, and a to the 5th plus the 7th, so it's 24a to the 12th. Okay. Pause the recording and do 2, 3, and 4. Go. Okay, so number 2. How about Alan?
I got negative 12. I got negative 12a to the 8th.
Perfect. Because that exponent is to the first power. Number 3, let's go with Bryce.
I got negative 18x, 3y to the 8th.
X, not 3y, x to the third.
Oh, yeah, I read that wrong.
One more time, read it correctly.
Negative 18x to the third, y to the 8th.
Y to the 8th, good. Number 4, how about Carter?
I got 30 a to the 3rd, b to the 6th, c to the 3rd.
Good. Okay, questions? All right. Let's move on. Okay, this is a little bit challenging. It goes a little bit beyond our lesson tonight, but you're going to need it nonetheless. So when we simplify things like this, we simplify each side of the subtraction sign. And then we combine them. Because remember, you can multiply and divide unlike terms, but you can only add or subtract like terms. And so let's simplify 7ab times 2a squared. What is that simplified to? Next to Shiva Maki. Annabella.
14a to the 3rd b.
B. Okay, now we'll simplify the other side. How about Alana?
5a 3b
A to the third.
to the 3rd b.
Good. And now we can subtract them only if they are like terms. Are these like terms?
Yes.
So I have an a to the third b, a to the third b. Yes, they are exact like terms. So if I have 14 a to the third b's and I take 5 of those away, how many a to the third b's do we have?
9.
We have 9 a to the third b's. All right, pause the recording and try the next two on your own. Shh. Can't, Connor.
Wow.
Cameron. Let's go back. Okay, Cameron. What did you simplify this first one to? We always start with coefficient first. So what would it be?
So negative 3 k to the fifth.
Right, that's a K1. K is to the fifth. X is to the what?
Fourth.
Good. Plus, what's the second one?
5 k to the fifth. X to the fourth.
Good. Okay, do they match? Are they like terms?
Yes.
Then they can be added or subtracted?
2 k to the 10th. X to the 8th.
No, to the 10.
Not to the 10th. The variables stay the same. If I have 5k to the fifth, 4 x to the fourth, and I take 3 of them away, how many of those terms are left?
5.
2.
Oh.
2k to the fifth,
So to the 7?
x to the fourth. When we add and subtract, shh, let me clarify. These are staying the same. The term is staying the same. Nothing happens. The rule that we were using earlier is only for multiplying like terms. These are being added. So the exponent stays the same. Okay, next one. Carter.
I'm just wondering, if the k's had different exponents, what would you do then?
You can't add and subtract unlike terms.
So,
You would leave it as two different terms. The terms have to be the same if you add and subtract them because the terms don't change. Okay, so what is the first one simplified to? A to the what?
Second.
And y to the minus? Oh.
Negative 6, a to the second.
wait, didn't it be
Shh. A to the second and y to the...
4.
Okay, so since that's negative, a negative times a negative makes a positive. Shh. Now what is it simplified to? What's going to be my coefficient?
6.
Coefficient will be 6. How many A's?
No.
A to the
4.
second, y to the fourth. Oh, wait a second. Are we right?
No.
What's wrong here?
Oh, it's 1A.
It's 1A. So it's really going to be 7.
Wait, never mind.
Shh. Okay? So, again, we're adding and subtracting like terms here. So you don't multiply the 6 and the 1. Because I subtracted 5, positive 5 minus 3.
No, on this one.
No, because that's not the coefficient.
And that one counts as 1A, then why doesn't that one count as 1Y? That one counts as 1Y. Making it 7A squared 2Y.
Hold on. I'm going to pause
You're
it.
adding 2.
Okay, so now we're going to go on to our dividing. Now, it stands to reason that if when we are multiplying like bases, we add the exponents. When we divide like bases, what do? Subtract. Now, if we expand it out, this is the reason. Now, I want you to notice something. Notice that when we cross cancel, right? What's left there? When I cross cancel, I'm left with a 1 and a 1. So I need you to know that because if everything gets cross canceled in the numerator, what are you left with? A 1.
Not a 0.
Not a 0, correct. But instead of expanding this all out, because what happens if we have x to the 49th power? We don't want to write... Okay, now I'm going to teach you this, and it's going to be a little bit uncomfortable, but you're going to need to think the way that I'm thinking for the rest of the semester. Okay? Now, the easy way is, obviously, we know that if we do the opposite, which would be subtracting our exponents, we end up with x to the third, right? We subtract top minus the bottom. But I'm going to show you another way, okay? So this is one thing. Here's how you're realistically going to get your questions, and they're going to ask you to simplify. I want you to think of this like two problems. Here's 10 over 15 and m to the fourth over m. This is two different problems, okay? Think it's really one problem, but I want you to think of it like two separate problems. Numerically, what's the greatest quantity I can divide out of both the numerator and the denominator? Go.
5.
5. So when I take 5 out of 10, I'm left with a 2. When I divide 5 into 15, I'm left with a 3. What's the greatest amount of m's we can divide out of the numerator and denominator? 1m. When I divide an m here, how many is left?
4.
When I divide an m out, how many is left? 3. So I'm going to say m to the third, not 3, because 3 is different. When I divide an m out here, m divided by m is 1. So in my numerator, what's left is 2m to the third over 3. We can also write that as 2/3. Drop the m to the third to the middle, not the denominator. Either of those is a final answer. Okay, pause it. Hold on.
Wait, I'm very.
Okay, so what I'm saying is if I expand this out, I'm really still just dividing 1 out. I always go with the smaller number and divide that out of both parts. Now, when I say divide, that really means we remove 1 from the numerator and 1 from the denominator. And what's left stays in the numerator or the denominator.
Couldn't you just think of as it was 15m to the first, so you just, and then instead of 15m, and then just.
Yeah, you can add that little 1 here. That's fine too. Okay. All right, let's try the next one. I need you to stop whispering. I'm recording and it's picking it up. Okay, so what common numeral will we divide out of 3 and 18? How about Dakota?
3.
3. So 3 goes into 3 one time and into 18 6 times. What is the greatest amount of x's we can divide out of numerator and denominator? Rami. 2 x's or x squared. Say x squared. So when I divide x squared by x squared, what am I left with? 1. When I divide out x squared here, what's left?
X cubed.
Good. So in my numerator, what's left?
You have x or 1 or x cubed
Over
6.
Good. We don't need to write 1x cubed. Okay, you guys getting it?
Yes.
Okay. I'm going to pause the recording. I'm going to move on. Now you see there's a lot of work here. And they're using the subtraction, but what I'm doing really helps you throughout the year, how we're going to need to do it. I'm going to skip some of these rules. We've kind of talked about them. Okay, here we go. Greatest amount we can divide out. What's the greatest amount? People I haven't heard from. How about Kate?
3.
Not 3, but x to the third. When I divide x to the third out, what's left? Okay, and when I divide x to the third out here, what's left?
1.
And so we are left with x to the fourth. Sorry, I should make that look like over 1. We don't need to write over 1. Okay, why don't you pause the recording and try 2 through 6. Okay, so y to the 19th over, what's our greatest common quantity that we're dividing out? Go, Cameron.
Y to the 11.
And what am I left with in the denominator?
Y to the 7. The 8.
In the denominator, what am I left with?
1.
1. And in the numerator?
Y to the 8.
Good. And so my final answer is?
Oh, Y to the 8.
Please don't raise your hand if you're not ready to answer it and you're busy looking behind you. Next one. David, what common number can I divide out?
2 and
2. I'm going to divide a 2, and I'm left with
3. Oh, no, 1.
1. And in the numerator, I'm left with
3.
and what greatest amount of m's?
1.
Okay, and I'm left with what in the denominator?
1.
And in the numerator?
M to the 7th.
And so my answer is 3m to the 7th. Okay, what can we divide out of the next one? Go, Ash.
You could divide by 1 for
1a. And what am I left with?
4,
A to the 4th. Say a to the 4th.
and then you could
And in the denominator, what am I left with?
1.
1. Okay. What am I dividing out now?
B to the second power,
Okay, and what's left?
B to the second power,
Over,
over 1.
which equals a to the 4th, b to the 2nd. You get the idea? Okay, let's check our other answers. I don't like the way they do it when they're doing the subtraction, which you can. And remember, when you're left with a 0 to power, what does that really equal? 1. Anything to the 0 power equals 1. And so t to the 0 power is 1. We just write 4k to the 3rd power. Okay? All right, I want to go on to negative exponents. Negative exponents are not negative numbers. What they really represent is fractional amounts. Okay? So what I want you to do is we break it down. Once you get to the fractional, to convert that to the fraction, the base comes down, it becomes positive, and I put 1 in the numerator. What does that simplify to? 1 over 3. Okay, what would number 2 be? 1 over 5. What about the next one? 1 over 4 squared, which is 1 over 16. Next one. Excuse me. I've not dismissed you. Okay, next. Keep going.
1 over 6 squared,
Which simplifies to?
36. Oh, 1 over 36.
1 over 36. Okay. When I have a negative exponent for a fraction, we basically take the reciprocal. We flip it. It becomes 4 to the negative 1 and 5 to the negative 1. Well, what do? The 4 comes down here to the positive, and the 5 goes up here to the positive. So it becomes 5 over 4. Okay, what about the next one? 2 to the negative 2, and 3 to the negative 2. So what does that simplify? Where does it go?
You flip it. And you
Flip it.
And you get 3 to the 3 squared over 2 squared.
Over 2 squared, which is 9 over 4. Okay, and that is our recording.